Hi, today in this video, we will be demonstrating capabilities of Aarna Networks multi-cluster orchestration platform, also known as AMCOP, with private 5G multi-cluster deployment. For this, we will be using Free5GC as the 5G core and OVN4NFV as the CNI provider. So from a private 5G overview, we expect deployments on various clusters spread across sites for different enterprises can be centrally managed by AMCOP, which uses OpenNESS-EMCO as the base, along with additional components like analytics platform, service discovery controller, private 5G configurator, network slicing, and CDS. Expanding view on an individual private 5G site, we can expect it to be a multi-cluster deployment where one cluster provides the 5G core, also the control plane, and the second cluster hosts the data path with respect to UPF and any application that needs to be available at the edge, co-located with the G-Node B. So emulating this into a demo setup, we are going to be using two single node clusters which are going to be managed by AMCOP from service orchestration perspective. And additionally, AMCOP would also extend multi-network service discovery and propagation for ease of connectivity. So OVN4NFV is going to be providing connection across cluster with the help of provider networks over VLAN, and Gnode B being the external simulator. So we are going to be having a pretty straightforward deployment with one cluster providing majority of the 5G core components. And on cluster 2, we are going to host the UPF, which is going to be associating with Gnode B. So as part of this demonstration, we will be showcasing capabilities of AMCOP with respect to orchestration and day zero configuration override. So what we will be showcasing is that we will be creating this application, specify intents, and then instantiate this application on the target clusters. So these applications further needs to have connectivity established with respect to various network abstractions as per 5G standard, and we look forward to to extend this with the help of provider networks. So we are going to be using secondary networks provided by OVN4NFV for network abstraction, and provider networks are going to help us connect microservices across cluster, and OVN action controller available as part of AMCO is going to help us generating the network intent. This is also in a production environment can be replaced by SRIOV based CNI, which allows connectivity as well as a faster access with the lower latency. Additionally, we are going to be using service discovery for connections over secondary network. For this, we have enhanced OVN4NFV plugin, and this service discovery controller in AMCOP also exports the services from one cluster to another, ensuring seamless connectivity for various components. Specifically in Free5GC, SMF needs to know the user plane information on how UPF and Gnode B are stitched together, which instead of worrying about the IP addresses for individual ports on the secondary network, we will be using DNS names. So once the deployment is done, we will be simulating this operation where GNB simulator is going to establish a SCTP connection to AMF for authentication. Upon getting association with a UPF, it will then initiate the data packets over GTPU tunnel towards the application. and back to the simulator. So with this, let's switch over to the demo. On AMCOP UI, we see that we already have two clusters, control plane and edge, available and pre-registered out of Aarna Lab. And they have already provisioned with the relevant networks that we will be using for this demo. So with this, let's move on to the project demo, where we have already pre-created two services, subscriber core with Helm charts of most of the Free5GC subscriber core components, and UPF with Free5GC UPF. So for reference, we would be creating the packet core service, which will include Free5GC AMF and SMF. So now we'll start the instantiation of these services, starting from subscriber core. So all the services for subscriber core are going to be on control plane cluster. Now we'll instantiate subscriber core. So in the cluster, we will see the relevant microservices will start coming up. So for this demo, we do not have 5G configurator integrated into AMCOP yet. So we'll be using the Free5GC's web UI of this deployment, which is exposed using Node port. So on the Free5GC UI, we would be creating the subscriber that we are going to use for our simulation operation. So this is the ID that we'll be using in our GNB simulator, and most of the other fields we will be using as is the default settings corresponding to it. So I'm leaving it untouched. I'll submit. So with this, let's instantiate rest of the components as well. Edge UPF. Which is going to be on edge cluster. Needs network N4 for connectivity with SMF. N3 for connectivity with the G0B. N9 for connectivity with UPF in the core. So we'll instantiate edge UPF as well, followed by core UPF. It's going to be on the control plane cluster. Needs network N4 for connectivity with SMF. N9 for connection from edge UPF. And N6 as the data network. So we'll instantiate the core UPF as well. Followed by packet core. So coming to packet core, we would be configuring some of the override values over here. So the key point to note over here is that we are pointing AMF and SMF to connect to the relevant NRF for registration. And then we are specifying the user plane information on how Free5GC expects information on how the GNB and UPF are stitched together, and all the slicing related parameters as part of it, and the IPAM that it is going to be using for the UE corresponding to a particular slice. So we'll be specifying this override values over here. And the interesting point over here is that we are not using specific IP addresses for the secondary networks. Instead, we are using service discovery based DNS names to address the interfaces. This essentially ensures that we do not have to rely on manual bookkeeping of IP addresses corresponding to secondary interfaces. So this is going to be on control plane cluster. AMF needs to have network N1, N2, and SMF is also going to be on control plane cluster and needs network N4. So we'll instantiate the packet core as well, which is instantiated. So now if we see all the pods corresponding to the services that we want are instantiated. And with this, we'll move on to the GNB simulator. So, so the simulator is configured to use the corresponding subscriber ID that we configured in the Free5GC UI. And it is going to be reaching out to example.com via UPF at the edge to the UPF in the core over network N9 and followed further to the cloud over the data network. So with this, let's initiate our test. So the CTP connection with the AMF is established, and it got the corresponding UPF association along with the IP address for UE. And this is where we see the probe for example.com returns status OK. With this, let me also take a moment to share a brief overview of roadmap for AMCOP. So we intend to include more features to make AMCOP a much more powerful platform for 5G, private 5G solutions. Specifically, we are looking forward to include a day-to configuration capability for deployed services. This will enable us to do eSIM provisioning. Then we are looking forward to contribute service discovery changes upstream for secondary networks and look forward to establish a uniform handling. We are also looking forward to enhance service discovery and make it more production ready for multi-cluster use case. We are looking forward to enable edge-triggered secure cluster discovery and registration, simplifying onboarding of new clusters into the environment. We are also looking forward to induct network slicing and traffic steering to the local application to achieve low latency use cases by bringing application closer to the edge. Further, as part of the dashboards, we look forward to include 5G configurator, which essentially enables us to program 5G core and ORAN components out of a single pane of glass integrated into the AMCO UI. making it much more powerful tool to deploy and manage a private 5G solution. Thank you.